At that time, you may press star 1 on your phone to ask a question. I'd like to inform all parties today's conference is being recorded. If you have any objections, you may disconnect at this time. Today's conference will begin shortly.
Welcome to today's media telecon, previewing NASA's OSIRIS-Rex asteroid sample delivery on Sunday. I'm Erin Morton with NASA's Office of Communications. After a 7-year journey to asteroid Bennu and back, the OSIRIS-Rex spacecraft is now just 2 days away from delivering NASA's first asteroid sample to Earth. The mission team is currently in the midst of completing final preparations to retrieve the sample capsule once it lands here at the Department of Defense's Utah Test and Training Range outside of Salt Lake City. We will begin today with some opening remarks and then leave time for questions afterwards. On the line with me today, we have Lori Glaze, NASA's Planetary Science Division Director from NASA headquarters, Sandra Freund, OSIRIS-Rex Program Manager from Lockheed Martin, Rich Burns, OSIRIS-Rex Project Manager from NASA's Goddard Space Flight Center, Dante Loretta, OSIRIS-Rex Principal Investigator from the University of Arizona, and Nicole Lunning, OSIRIS-Rex Curation Lead at NASA's Johnson Space Center. As I said, we will take questions from the media after these presentations, and if you're a member of the media on our telecon lines and would like to ask a question, please press star 1 to be put in the queue. And with that, I'll turn it over to Lori Glaze.
Thanks so much, Erin. So, as you all know, NASA has an amazing planetary science mission fleet comprised of nearly 40 missions that are either in formulation, implementation, or operation. And 7 of those missions are focused specifically on what we call small bodies, such as asteroids. And there are several distinct and diverse populations of asteroids that are found across our solar system. And each one of those populations of asteroids can tell an exciting chapter of our origin story. Scientists believe that the asteroid Bennu is representative of the solar system's oldest materials forged in large dying stars and supernova explosions. And for this reason, NASA is investing in these missions devoted to small bodies to increase our understanding of how our solar system formed and how it evolved. Right now, we are ushering in a new season. We are very excited for what we're calling Asteroid Autumn. And we're kicking off Asteroid Autumn with the arrival of the OSIRIS-Rex samples on Sunday morning. We've waited a really long time, and now those samples are only 2 days away. You're going to hear a lot more about that in a few moments. In addition to OSIRIS-Rex, 2 days later, we're going to celebrate the first anniversary of the historic double asteroid redirection test IMPACT, which proved a concept that could one day help us defend our planet from potentially hazardous asteroids. And then, in the beginning of October, we're going to launch a mission called Psyche that's going to visit an asteroid also named Psyche. And that mission is headed to this never-before-seen metal-rich asteroid, one of only 9 of such these metal-rich asteroids. And then at the 1st of November, the Lucy spacecraft will fly by an asteroid named Dinkinesh in the inner edge of the main asteroid belt. This flyby will serve as a risk reduction and a test of Lucy's autonomous terminal tracking system in advance of its prime mission to study what we call Trojan asteroids that lead and trail Jupiter in its orbit around the Sun. Dinkinesh will actually be the smallest main belt asteroid ever explored. So with that, I don't want to take up any more time. I'd like to hand things over to Sandra Freund.
All right, thanks, Lori. So I'm here at the Mission Support Area at Lockheed Martin in Littleton, Colorado. Everything here is going extremely well on the spacecraft. We have a large team here, our navigation partners from Kinetic Aerospace, our entry, descent, and landing team, members from Langley. So it's really quite exciting here. Everybody really feels the buzz of being less than 2 days away from having the Bennu samples on the ground. So to walk you through kind of high level what has happened and what is coming up, we did perform an Earth targeting burn on September 10th, and then we made a minor adjustment to our trajectory on September 17th. No additional maneuver opportunities were needed. The spacecraft trajectory and performance has just been spot on. So we have just a few remaining steps before we have Bennu samples on the ground. We will need to adjust our spacecraft pointing. So we'll need to get into our sample return capsule release attitude. There is a go, no-go decision point that will take place very early Sunday morning. And that is showing that the spacecraft is ready, our trajectory is spot on to the Utah test and training range. We fully expect to leave that meeting on Sunday morning with a go decision. So we will send the go command to the spacecraft, which will allow it to start its release sequence. That release sequence will configure the sample return capsule by putting its batteries online and activating the avionics inside of the sample return capsule. Then we will fire the pyros to cut cables and release the SRC at about 4:42 a.m. Mountain Time. We've got 4 hours from release until entry. Once the sample return capsule senses entry with a 3G sensor, it will start a timing circuit. That will deploy our drogue parachute for stabilization, followed a few minutes later by our main parachute, which will slow the return capsule down to a nice gentle 10 to 11 mile per hour touchdown. Now, this sample return capsule is heritage to the very successful Stardust mission, and we are very much confident that all will go exactly as planned on Sunday morning. Our navigation and spacecraft performance has been exceptional. We are headed right for our landing lips at the Utah test and training range. So I'm going to turn it over to Rich Burns to talk about what happens for recovery.
Thanks very much, Sandy. So once the capsule's on the ground, actually before the capsule reaches the ground, our colleagues here at the Utah Test and Training Range have sensors that will be tracking it upon its descent. We'll also have NASA airborne sensors that will be able to likely be able to pick up the capsule as it enters the Earth's atmosphere, begins its, the atmospheric entry will heat up the sample. So tracking assets will include infrared sensors that will be able to detect the high heat emission from the capsule itself during reentry. Once it's on the ground, we'll be executing a helicopter-based recovery. There are 4 helicopters involved in that. They'll be transporting our colleagues, first our colleagues from the range, who will verify that the site is in fact safe to approach, followed by our colleagues from Lockheed Martin, who will examine the capsule itself and make sure that it is safe, both cool enough to touch, and if not, we have some gloves that we'll be using to gloves similar to what you'd barbecue with. It won't be extraordinarily hot by the time it's on the ground, but we'll be ensuring that there is a battery inside that, if it were to rupture, would emit temporarily some toxic fumes. And so you'll see the first people approaching the capsule wearing masks as a precaution, and then taking measurements to determine whether the area is safe to approach. At that point, our colleagues from Lockheed Martin who are primarily responsible for effecting the recovery of the capsule, will approach and begin processing the capsule for its transport back to a clean room here at the Uter. Meanwhile, the science team will approach, and Dante will talk to you about that, and they'll be sampling the area around the capsule to catalog the local environment. I want to emphasize that success for the landing day itself results in transport of the capsule, safe transport of the capsule back to the Avery complex here at the Uter, and establishment of a high purity nitrogen purge onto the capsule inside a temporary clean room that my colleague Nicole Lunning will talk to you about. With that, I'm going to turn it over to our PI, Dante Loretta.
Thanks, Rich. It's great to be here, less than 2 days out from the end for me, what's been almost a 2-decade-long dream and job and exciting adventure. As the principal investigator, it's my job to ensure the scientific integrity of the entire OSIRIS-Rex mission. That's a promise I've made to Lori and to our stakeholders at NASA and elsewhere. I'm also thrilled to be on the environmental field team. One of the key scientific objectives of OSIRIS-Rex is to return a pristine sample, and pristine means that no foreign material hampers our investigation during sample analysis. As unlikely as it is, we do want to make sure any materials that are out there in the Utah range that may interact with the sample are well documented. So along with Francis McCubbin from NASA's Johnson Space Center and Scott Sanford from NASA Ames Research Center, we'll be collecting a series of different samples to document any kinds of material that may have encountered the sample return capsule. This includes dust particles, air samples, gases from nearby the spacecraft. As Rich mentioned, the heat shield will be getting very warm. The good news is the sample inside the capsule will stay nice and cool, but nevertheless the vapors might interact, so we'll have documentation of that. We'll be collecting soil samples, and if there's any water on the range, we'll be collecting water samples as well. My job at this point is to really make sure that we're just keeping a scientific eye on the process as the capsule gets delivered to the clean room, where Nicole Lunning, who you'll hear from soon, and her very capable team will be taking outstanding care of the material, making sure it gets all the way to the clean room at Johnson Space Center. So what I'll be looking for is any indication that there might be a concern from the scientific perspective. Like I said, everything is very low probability event, but OSIRIS-Rex has been so successful because we continue to pay attention to the details, thinking through all possible contingencies. For example, if the sample capsule were to open even briefly, we would want to make sure any sample material that made it onto the Utah desert floor was quickly identified and recovered so that we could still extract meaningful science from it. And of course, what we're really looking forward to is working with Nicole and her team over the next weeks and months to investigate the sample, understand the nature of the collection, and then begin allocating it to our sample analysis team, which is international in scope. We have over 200 researchers using over 60 different analytical techniques to interrogate this material to understand, as Lori said, processes that occurred even before our solar system existed, the nature of material processing in the protoplanetary disk, accretion of asteroids, geological processes that might have occurred in those asteroid interiors, the formation of Bennu itself as a distinct object, which may have occurred about 1 billion years ago, and its transport into the inner solar system to become a near-Earth asteroid. So we have a very impressive and ambitious sample analysis program, which will be playing out over the next 2 years. And with that, I'll turn it over to Nicole to talk to you about the details of the curation team's activities.
Yeah, thank you. So after the sample return capsule is collected in the field and brought back to where we've set up a temporary clean room. We'll actually bring that capsule in. We'll do a little bit of cleaning because we are now expecting it to be a little muddy to get the mud off before it comes in the clean room. And then one of our biggest milestones here in Utah is establishing what we call the purge, which may sound like a scary thing, but for us it's a really good thing, which is a nitrogen flow or purge that will be attached partway through disassembly, and that flow will prevent any of the terrestrial atmosphere from getting into the canister where we expect most of the sample returned asteroid Bennu material to be. And so that will be a point at which we will take a sigh of relief and be able to just relax a little bit for the rest of the sample return capsule disassembly. And some of our colleagues will actually take a lunch break, and the curation team will be looking through and processing some of the parts that have come off. Basically, we are going to take the two biggest things, the things you see on a sample return capsule. Our colleagues from Lockheed Martin will first take off the back shell, where the parachute canister is attached, and then after that, a few other items will come off. That purge that I mentioned will be established on the canister, which is inside, and our colleagues will have to flip the canister over to then remove the heat shield, which when it comes in is on the front end of the capsule. So those really big parts will then basically strip down to this container on the inside, which is called the sample or science canister, and that we will actually wrap up still on its nitrogen flow purge, get into a shipping container, all the while maintaining that nitrogen purge, and that shipping container will go onto an aircraft, which will fly from here, where we are in Utah, to Ellington Air Force Base in Houston, and then will be driven to Johnson Space Center to Building 31, where we have our new curation lab that was specially designed to be the long-term permanent home of the sample, from which we will be able to allocate first to the science team that Dante is leading, and then to more scientists all over the world.
Thank you, Nicole. So we will now open the line up for questions. Again, if you are a member of the media on the telecon line, please press *1 to be put in the queue. So operator, let's begin. Our first question will come from Gina Sinceri from ABC News.
Hi, I'm here. It sounds like you guys have got everything in hand and you'd like the weather to be a little rainy. Is that right, Nicole?
We have already gotten some rain here this week in Utah, and so we're not expecting it to have fully dried out to full desert playa conditions. We'd prefer it not to be raining on landing day if we can help it. For the most part, less water is better, but we are prepared for it to be muddy, and the field team has done mud rehearsals, which Dante could tell you about as well. So we're going to roll with what nature has given us.
Yeah, the forecast between now and then is favorable, and our colleagues here at Utah Test and Training Range are well experienced in operating in all these conditions. So we're highly confident that we can effect an efficient recovery.
And I just wanted to point out that the first answer came from Nicole Lunning, and the second came from Goddard's Rich Burns. Okay, so Gina, is that?
I'm sorry, I didn't hear you.
Oh, I was just saying, did that answer your question?
Yes, that answered it very well. Thank you very much.
Thank you. Our next question comes from Christopher Kokinos from Astronomy, from Astronomy Magazine.
Yeah, hey, thank you for taking the question and good luck this weekend. This is a sort of a two and a half part question for Dante. At the press event in August, you had talked about Bennu having hydrothermal deposits, like the Earth's deep ocean environments. And I just wanted to clarify if you meant those were relic deposits or systems, or if they were in fact active, if you have knowledge about that. And then you had talked about, you might be able to get samples of long chain molecules, and I'm wondering if you could talk a little bit about what those would be, if those would be pyrophosphates or other things. And I appreciate the time that you guys are giving us. Thank you.
Thank you, Chris. Those are two great questions. So I'll take your first one. Bennu itself is geologically inert, so we don't see any processes associated with hydrothermal activity. There are some surface activity like particle ejection events and maybe mass movement downslope, just due to the gravitational potential across the surface of the asteroid. When we look at what might be hydrothermal deposits, we postulate that those occurred very early in solar system history, probably within the first 10 million years, because Bennu is a fragment, we expect, of a much larger asteroid on the order of 100 kilometers in diameter. And when those bodies accreted in the protoplanetary disk, there was a high abundance of radioactive elements. It looks like Bennu's parent asteroid also accreted icy material. And when you put those two together, heat and ice, you're going to get hot water. And that hot water will react with the minerals that originally accreted, going from what we would say are anhydrous, like silicate minerals and metals and sulfides, reacting with water to produce more hydrated phases like phyllosilicates or clay minerals, evaporite deposits like carbonates, and other minerals characteristic of aqueous activity, for example, an iron oxide called magnetite. And to your second question, one of the key objectives of OSIRIS-Rex is to characterize the organic molecules that may have been delivered to the early Earth by these carbon-rich bodies. And we expect that we'll find what we call monomers, or very simple molecules, for example, amino acids, which many people may be familiar with because they make up our proteins. And if you take protein supplements, you can often see the list of amino acids that are included in that. What would be really exciting is if we saw any evidence that those amino acids have started to link together to form a chain, which we call peptides. It would give us some indication that towards the evolution or towards the origin of life, protein evolution may have occurred. And I want to say that's a hope. It's probably a long shot, but it would be a spectacular science result if we were to discover something like that.
Thank you, Dante. Next, we have Stephen Clark of Ars Technica.
Thanks for taking my question. I think it's kind of a simple logistics question. If everything goes according to plan, what's the earliest you could open the lid to the canister? And also, you have an estimate of how much material you're bringing back, but when will you actually be able to measure the mass of the material? Is that something that can be done before the lid is opened, or do you have to open the lid before you can determine that? Thanks.
Hi, this is Nicole, Lunning, Johnson Space Center. I'll take at least two of those three questions. We do not have a way to measure the mass before we take the lid off, so we are going to do all the mass measurements after the canister lid comes off. The earliest we could take it off in a nominal scenario is on Monday, September 25th. That's if everything goes actually slightly ahead of schedule. We have possibility that it could happen. We do expect to have the lid off in a nominal scenario no later than midday on Tuesday, September 26th. So we should have it off by then. Dante, do you want to answer the question about the mass?
Sure, and maybe Sandy will want to comment as well. So when we collected the sample from the surface of the asteroid in October of 2020, we realized that there was a concern with the sample collector and material was being lost to space, which prevented us from doing the plan to measure the sample mass using a moment of inertia technique. However, we have a very capable and creative spacecraft team at Lockheed Martin in Denver, and they were able to look at momentum transfer from the robotic arm to the reaction wheels on the spacecraft, and we have an estimate of 250 grams plus or minus 101 grams of material inside the canister. And that's good news because the mission requirement, what I promised Lori and the headquarters team, was that we would bring back 60 grams. So even at the low end of that estimate, we're well above our mission requirement.
Thank you. Next, we go to Ramin Skiba from Wired magazine.
Hi, thank you. Excuse me. This is a question, I think, for either Dante Loretto or Nicole Lunning. I was just wondering, on October 11th, will you also have any sort of preliminary findings or results to share, at least based on, like the dust that's on the outside of the canister that probably came from the asteroid?
Thank you. That's a great question. We hope there's no dust on the outside of the canister. That would not be a nominal scenario. But we do expect that there might be fine-grained material on the inside of the canister and visibly accessible right after opening it, as Nicole said, on Tuesday, September 26th. So we have a plan to sample that material. We have a team of analysts standing by, we call them our Tiger team, to perform quick look analysis of that material. That's being led by Lindsay Keller from NASA's Johnson Space Center and Professor Tom Zega from the University of Arizona. And we're going to use the amazing array of scientific instruments that are on site at JSC to get an understanding of at least the fine-grained material. Of course, there has to be fine-grained material present in the interior of the canister because we will be taking our time to remove tag SAM where we expect the bulk of the material to be. But we are ready to begin sample analysis the day after the sample arrives in Houston, and we're hopeful that there is material accessible immediately upon opening that canister.
Great, thank you. Next, we have Marcia Dunn from AP.
Yes, hi. I was just looking for a timeline for Sunday after touchdown. If everything goes according to plan, how long do you think it'll be before the capsule is actually in the temporary clean room? How long after touchdown? And once you get it into the temporary clean room, how long will it take to get it out of the actual capsule, remove the heat shield, all that sort of thing? If you could go through the timeline, please. Thanks.
Sure. This is Rich Burns. If everything goes to plan, the sample could be dropped off in front of the building housing the clean room, temporary clean room, before 11 a.m. Disassembly inside the clean room could begin as early as 11:30, and disassembly could be completed before 5 p.m. local.
Excellent. Next is Katrina Miller from the New York Times.
Hi, everyone. So I'm aware that the capsule was overflowing after you grabbed some regolith from Bennu, and I've read that it was sort of like wedged open. But can you explain how, like, if the canister was wedged open, how it was managed to be closed and stowed? Like, did you have to dump anything out or dislodge chunks of it that were wedging it open? And did stowing it so quickly, however long that took, mean that you were able to save material that otherwise would have leaked out?
Sandy, do you want?
Yep. Sorry, this is Fran. Yep, this is Sandy Freund. I can address your question there. So when we saw that the bottom of the sampler head was wedged open, we stopped moving on the spacecraft to not lose any additional material. And then we moved to stow that in our sample return capsule as quickly and safely as we could. So there wasn't anything we needed to do. There was no obstruction in taking that sampler head and putting it, snapping it into what we call the capture ring inside of the return capsule. So the only change we needed to make was to not do any additional movement. That's why we didn't conduct the sample mass measurements that Dante had discussed, and to accelerate our timeline.
Yeah, you can think of it as sort of a salt shaker, right? We wanted to minimize the motion was really what precipitated, so to speak, I guess literally, the escape of material from the collection head. So what we did was minimize motion.
Yeah, and I think it's important to remember the architecture. There's the tag SAM, which was the actual device that contacted the surface of Bennu. That was what was wedged open, and that was placed inside the science canister, which is inside this capsule assembly. I think Nicole uses the metaphor of a nested doll, which I think is a pretty good one. So the canister, there were no issues with that getting sealed up, And so the tag SAM is safely inside of there, and at that point, it didn't matter if it was wedged open because the sample was safely contained inside the canister.
Great. The last two, that was Rich, Burns, and Dante was the last.
Thank you.
Okay, next we have Marcia Smith from spacepolicyonline.com.
Thanks so much for taking my question. SETI said that you expect to come out of that meeting, the no-go meeting with a go, but what factors will you be looking at? What might cause you to say no-go? And if the parachutes don't fully deploy or deploy at all, can the canister survive a direct impact with the desert floor?
So the factors this is Rich Burns, the factors that will lead to the go, that are under consideration in the go, no-go decision, largely boil down to landing accuracy. We have a set of criteria that we know will be satisfied if we're landing in the area that we have prescribed here at the Utah Test and Training Range. And we know that the trajectory we're currently on, and we're not planning to make any more maneuvers, it fits well within that landing accuracy. So we fully expect that this is going to be a very easy decision to make at 2 o'clock in the morning. It's good to have easy decisions to make at 2 o'clock in the morning. But it all boils down to that. Do we fit into our landing region, our defined landing region at the range? Maybe Sandy could comment on the SRC impact under hard impact.
Yeah, this is Sandy. I can certainly comment on that. There are a lot of factors that come into how the SRC lands right in a no-shoot, partial shoot type scenario that you're envisioning there. The recovery team is ready for any of those scenarios. The first priority is human safety first, and the second priority is sample safety. So the team is ready to, once it's safe to approach the SRC, whether it be intact or not, they will be looking to get the bulk sample under purge as quickly as possible. So that is the plan. The team has rehearsed that. They're ready to go. So they'll very unlikely. There are plans and procedures in place in the event that the science canister is breached.
Could I have a follow-up to that?
Sure.
So are you going to have drones or something flying over the capsule to determine whether or not it's been breached, or how would you know that remotely?
So there, as I mentioned, this is Rich. There'll be 4 helicopters in the area, be staged outside of our prescribed landing area prior to entry and descent and landing. They will be overflying the region, and so there'll be visual acquisition on the ground prior to landing, and examination of the capsule will follow at ever closer distances, right, to examine it for damage.
Thank you.
Thank you. Next on the line, we have Georgina Torbett from The Verge.
Hi, guys. Thanks for doing this today. So I have a couple of tech questions for Sandra. Firstly, I was wondering how you chose this particular location in Utah. Like, what is it about this environment that makes it suitable for the landing? And secondly, you mentioned that you were going to do the go or no-go decision on Sunday morning. And can you tell me, in the unlikely event that it is a no-go, is there another opportunity for a landing, or is this it? Is this the only chance you're going to get at this? Thank you.
Yeah, so this is Sandy. The Utah Test and Training Range is chosen because it has the largest restricted airspace in the United States. It's also where we did return both Genesis and Stardust previously, so we have some history there. In the event of a no-go, an unlikely no-go decision on Sunday morning, there is an opportunity for an Earth return in September of 2025.
Okay, so would that be when OSIRIS becomes OSIRIS Apex and goes off to Apophis, you could do a return to Earth during that time. Would that be it?
Yeah, our trajectory will bring us back by Earth in the September 2025 timeframe, and so that's an opportunity for us to then target for an SRC release, a sample capsule release opportunity, or for an Earth gravity assist for APEX.
Okay, super. Thank you.
It is an either or, right? If we miss this opportunity, we would not be making an extended mission to Apophis in order to return to Earth in 2 years. And I'll just add to the range question. Our colleagues here at the range are amazing at their ability to locate, to track, locate, recover assets on their range, and it's a great pleasure to work with them. They've been amazing and have a great deal of confidence in them.
Great, thanks.
So next we have Alexandra Witze from Nature magazine.
Hi. Assuming everything goes well on Sunday and everything gets flown off to Houston, what happens if the government shuts down on the 30th?
Hi, this is Lori Glaze. I think I'll take that one. So, as y'all are aware, I know, in the event of a possible government shutdown, I'll just say that while that's disruptive to our process, it will not endanger the curation safe handling of the asteroid sample that OSIRIS-Rex has received and is bringing back from Bennu. Certain steps leading to its highly anticipated analysis will possibly be delayed, but the sample will remain protected and safe despite any unforeseen disruptions to the schedules. And we all need to kind of take a deep breath here. We will make sure, first and foremost, that this sample is safe and not at risk. And we have time for that after it returns to Johnson Space Center on September 25th. And just as we all think about this, the sample's waited for more than 4 billion years for humans to study it. And if it takes us a little longer, I think we'll be okay.
Thanks.
Thank you. Next we have Ivan Semyonek from the Globe and Mail.
Hi there. Thank you for this opportunity. It's Ivan Semyonek from the Globe and Mail. I just wanted to ask a science question and hopefully also an engineering or logistics question. The science question has to do with opening the canister. I'm just wondering if there is time-critical science that would have to happen right away. Maybe it's associated with volatiles or something else, something that would be first on the list, highest priority, and also what temperature the sample will be at when this is done. The engineering question has to do with just the re-entry. It was mentioned during the August news briefing about the Genesis capsule, which failed to deploy a parachute and of course made a hard impact and the canister breached. It was mentioned at the time that a lot has been learned since then. I'd love to hear a little more detail on what has been learned to ensure a better outcome on Sunday.
Okay, I'll take the first part of the question. This is Dante Loretta from University of Arizona. And we did target asteroid Bennu particularly because we think it may contain a lot of volatiles. And when we say volatiles, we mean things like water molecules, again, locked up inside clay minerals, not as liquid water or ice on the surface of the asteroid, and carbon in the form of organic material. The sample return capsule itself has a filter assembly which would catch any material that has been outgassing. You got to remember it's been 2.5 years almost since we departed Bennu and almost 3 years since we collected the sample. And so it's been exposed to temperatures, room temperature, over that duration. So we expect any outgassing that might have occurred would be documented through that filter, and also witness plates that are strategically placed around the interior of the canister as well as on the tag sampling device itself. We will be, of course, looking for those materials. We also have the nitrogen cabinets at Johnson Space Center, which is under constant flowing dry nitrogen, and there will be some filters placed on the exhaust to catch any material that may be liberated as the handlers are processing material inside the cabinet. But nothing is time critical to the point where we need to get it going right away. We feel, I think as Lori said, It's been over 4 billion years, and so we're going to be deliberate, very careful. There's really two objectives. One is to perform the science investigation, and the second is to preserve the long-term integrity of the collection, and everybody on OSIRIS-Rex is fully dedicated to both of those objectives. And I'll turn over the second part of the question to whoever wants to take it.
Let me field first, and maybe Sandy can add my question. So this is Rich. So in response to Genesis, NASA had an extensive mishap investigation board, right? And not only was the specific cause found, in other words, there was a switch that was had a polarity issue in its installation, right? But further causes having to do with the processes used to build SRC and test, right, were discovered and made more robust in response. And consequently, right, we have a great deal of confidence that the same type of failure will not recur in this mission. Also, there were some onboard avionics changes, I think, in the SRC that Sandy may want to comment on.
Yeah, this is Sandy Freund out here at Lockheed Martin. The Genesis capsule and the OSIRIS-Rex capsule are actually quite a bit different in terms of size and a little bit in terms of avionics. And so the OSIRIS-Rex capsule is heritage to Stardust. As Rich mentioned, there was an extensive investigation into that. Any failure as well as any success provides lessons learned, and we always take those forward, mainly in qualifying heritage design and ground testing. And I can tell you that we definitely took those lessons learned forward on OSIRIS-Rex, and the ground testing was performed to ensure that the issue on Genesis does not exist in our hardware.
Thanks for that.
Thank you. Next is Leo Enright from Irish Television.
Thanks very much. My question, to be honest, has been broadly answered by the Genesis question, but I was just wondering about lessons learned from previous missions like Hayabusa, Stardust, and Genesis. Could you maybe just give a general synthesis of what you think you've learned, and how also, looking forward, how much this mission will feed into a potential, I'm sorry for laughing slightly, but a potential Mars return sample?
Well, I can tell you, this is Rich again, I can tell you that we have a very strong partnership with our colleagues at JAXA, and they invited us to consult with them and share their experiences on Hayabusa 2, and we have done so, and Hayabusa 1 for that matter. And so we have a very collaborative relationship. We've established some discussion around how we operated in proximity to the asteroid, as well as how the sample was collected. That was quite a bit different on the Hayabusa missions than ours. And then, of course, we talked about the Genesis investigation, but you said that. Okay. So, yeah, I'll leave it at that.
And Lori?
Yeah, Leo, this is Lori. Good to hear your voice. I think we've gotten to speak in a while. But good question. And of course, you mentioned Mars sample return, and as we always do, trying to continually learn from every single mission, as you heard from the Lockheed Martin team about learning from Genesis to make sure that that doesn't happen again here, and we will continue to learn from every mission that comes before to make sure that we are building the most reliable system that we can.
All right, thank you.
So following on with Lori, for curation, we're all in the same building. The Genesis Curation Lab is a floor down from us, and how we're going to take care of the sample incorporates lots of lessons learned from from those previous missions. I also want to give a call out to Genesis that even with the crash, that fundamentally changed our understanding of the geochemistry of our solar system, and we are anticipating everything to go well. We have a lot of confidence, but we're also preparing for the worst and would do everything we could to make sure that this mission also can do that. So there's a tremendous amount from Apollo to Antarctic meteorites to Stardust that has fed into how we've designed our lab, how we're going to handle the sample, as well as things that are totally new for OSIRIS-Rex, designing very custom glove boxes and other ways that curation will process the sample. Thanks.
One last thing, this is from Rich. On this mission, we take very seriously documenting our own lessons learned, and there were many in terms of how to operate around a small body, and particularly the challenges that Bennu posed. And so we are committed to documenting that for future missions, in particular small body missions.
Thank you. All right, next we have Brett Tingley from Space.com. Brett, are you on the line?
Yes, can you hear me now?
Yes.
Thank you. Thank you all for doing this. I'm just wondering, after the sample has been removed from the capsule, what's going to happen to the capsule itself?
So all of the returned hardware items actually will become part of the OSIRIS-Rex flight collection. So they'll be curated at NASA Johnson Space Center. And you can imagine that the interest in them will be different, but the things like the back shell and heat shield, even that come off here, will ultimately come to Johnson Space Center for long-term curation and may be available for space-exposed hardware studies or other similar kinds of scientific or public uses.
Thank you.
Next we have James Reardon from the Science News magazine.
Cool, thank you. So I have two questions. One is, you had mentioned, somebody had mentioned that there was going to be a team that would check to see if the capsule was safe to approach, and I was wondering what criteria do they have in mind? What might make it unsafe to approach? And my second question is, will we be able to watch the opening of the capsule by a live stream by any chance?
This is Rich. I'll take the first, right? So we are operating on a munitions range. So the first order of business is to ensure that the area around the capsule is safe and free of any hazard that such a range may pose. And then the second is there is a battery on board the capsule. Well, first, the capsule was very recently at 5,000 degrees C, so we want to, Fahrenheit, excuse me, and we want to ensure that the temperature of the surface of the capsule is safe for people to touch. If not, as I said, there's gloves available for the team to process the capsule. And then secondly, there's a battery on board that if it were to rupture, right, we don't expect it to rupture, but if it were, it would temporarily vent toxic fumes, and we want to make sure the area is clear of those fumes prior to approaching the capsule without any protective gear on. So that's why you'll see people with protective masks on first approaching the capsule until we verify those fumes are not present.
So regarding your question about the canister opening, for both the SRC opening here in Utah and the canister opening in Houston, we will be recording them, but we will not be immediately live streaming them. So we will share that later, but it will be shared on October 11th when we do a sample reveal event. So all of that will be made available.
Okay, thank you. I have one quick follow-up on the battery, and is it a chemical or a nuclear battery?
It's a chemical battery.
Thank you.
Thank you. And next we have Lucy Oberg from AFP.
Hi, thanks for taking my question. Could you give a little more details about the purge, the nitrogen purge that you were talking about? I'm just not familiar with it. So concretely, does it happen in the entire clean room? How does it work? And how do you maintain it during the trip to Houston? Thank you.
Yeah, good question. So the nitrogen purge, it will actually be a line that's connected to a bottle of compressed high purity nitrogen, well, frequently it's called a K bottle, and that will actually go through a purge box that Lockheed Martin has actually used on several missions that will control the flow of that nitrogen. And that line will then connect to the canister through a needle that will go into a septum that was designed as part of the canister. So the septum's flown with the canister throughout its mission. And that flow of gas in a controlled way will then be going into the sort of cavity of the canister, displacing and preventing incursion of terrestrial atmosphere. So that flow or purge is really how we protect the sample. Oh, and we will be, part of the benefit of doing compressed nitrogen bottles as our source is they will literally go on a rolling cart. That purge box will go onto the airplane with the shipping container that the canister will be inside of. They'll travel on the airplane to Houston, and then also they'll roll off the airplane and be secured on a truck with the canister to be driven to Johnson Space Center, and we'll go with the canister into the building where our labs are.
All right, next we have a question from Dariana Davis from Forbes.
Hi all, thank you. I'm just wondering what protective measures you all will be taking in order to preserve the integrity of the sample when sharing it with CSA, JAXA, and other scientists.
So we will do all the sample handling in glove boxes. So the canister lid will actually come off inside of a nitrogen glove box. So it's an isolating glove box with a almost pure nitrogen atmosphere that's supported from our in-house nitrogen system at NASA Johnson Space Center. And we'll actually seal the samples for our international partners in those glove boxes and containers that are able to hold that pure nitrogen or anoxic, because oxygen and humidity are our biggest terrestrial concerns at first, at least, to protect the sample. And all of those items that the sealed containers that our international partners samples go into will have gone through precision cleaning to prevent contamination as well. So that will allow us to separate their samples, and then those very well sealing containers will be used to ultimately transport to our partners.
Okay, we are getting closer to the top of the hour, so we have time for just a few more questions. Next question is coming from Jana Sunseri of ABC News.
Yes, I think this is for Sandy. How precise did this mission have to be to make this all come together?
Yeah, this is Sandy, and that's a great question. I mean, the really precise navigation required to orbit Bennu and to touch down and touch and collect our sample, we were under a meter away from the target. So that kind of illustrates what kind of navigation precision we've had throughout this mission. We have a much larger ellipse on the Utah Test and Training Range than we did on the surface of Bennu for sample collection. But our navigation team is outstanding, and I fully expect us to be very, very close to the target when we touch down on Sunday.
Okay, thank you. It looks like we have one final question from Marcia Dunn of AP.
Oh yes, you mentioned that the final lid will come off maybe Monday or Tuesday at the latest. For you, Dante, how many days? I mean, I don't think you're going to know immediately, but once the lid comes up as to how many grams you actually got. So how long will it take for you to have a real assessment of how much you were able to bring back?
Yeah, I think that's a question for Nicole. She's the lead curator and responsible for those activities.
Yes, and you are absolutely right. We will not know immediately how much sample we got back. We'll see the tag SAM for the first time since it was stowed at Bennu, but we will have to actually weigh the sample in a handful of different ways in containers that we're able to weigh themselves and tear. So we expect to have an estimate of the bulk sample within about a week, and it may take us 2 or 3 weeks to have the highest precision measurement as we really, the TAGSAM, it did an amazing job collecting the sample, but we are going to need to take some time to get it all the way disassembled and get the sample out of it. And so that will be the reason why it takes us a little while to get to it, while also protecting the rest of the return sample items like the contact pads, which we haven't talked about yet, but may have collected surface particles and are part of the disassembly, and protecting those as low mass probably, but unique samples that are part of our collection.
And I just want to add that this is the hallmark of OSIRIS-Rex from the very beginning of concept development through design, build, test, launch, operations, and now sample curation and sample analysis. We've always taken deliberate, careful, cautious approach, and I think that's why this mission has been so successful up to this date. We don't let our enthusiasm get ahead of us, and we have, reaped a lot of dividends because of that. And we all respect the need to take care of the sample, as I mentioned, both for the science, but also for the long-term integrity of the collection.
Thank you. And this concludes today's media telecon. Thank you to everyone who dialed in today, and I'd also like to thank the panelists and our operator, Dustin, for their time. If you joined today's telecon late, you can listen to the entire recording by dialing 1-866-511-1895. Again, that number is 1-866-511-1895. Thank you, and go OSIRIS-Rex.
Go OSIRIS-Rex.
Thank you for participating. You may disconnect at this time.